Okay, so we're back and we're going to start talking about this question that we have in front of us. So let's just read it again one more time. Find to the nearest integer the length of the base of an isosceles triangle. So I would draw an isosceles triangle on your paper if I were you. An isosceles triangle. If the measure of the vertex angle, now the vertex angle is the one that's up on top. The vertex angle is 84 degrees 15 minutes. And the measure of each leg is 12. So in an isosceles triangle, we call this the vertex. These are the two base angles. These two sides are each legs, and they are always equal to each other. And then this is the base. So we have leg, leg, base. Two base angles and a vertex. So you really need to know your geometry to fill in that kind of stuff. Okay, so we're going to find the length of the base of an isosceles triangle. So we are trying to solve for the base down here. We're trying to figure out what this is equal to. And let's call it x. So notice that we can use the law of cosines because we have side, angle, side. So the reason why we can use this is because we're given the angle across from this side. Okay? So let's use that equation. Now, this is the side length that we're going to start with because it's across from the angle. So our equation is going to be written like this. X squared is equal to 12 squared, because that's the other leg. And I'll pull this up for you if you can't remember what the equation is. 12 squared plus 12 squared minus 2 times 12 times 12 cosine of, now this is 84 degrees 15 minutes, but we just did a conversion and that's 84.25 degrees. You can do it either way because you're going to type this thing into your calculator, but personally I just like degrees better, so I switched it, but you don't have to. So this is the same thing as before. Because we are solving for this side length, all we need to do is type all of this stuff into our calculator, and the calculator is going to do all the work for us. So let me pull up my calculator, and let's type that all in. 12 squared plus 12 squared minus, now remember all these are being multiplied, so I want to put it in parentheses just in case. 2 times 12 times 12 times cosine of 84.25 degrees. Close those parentheses. Right there is where you would type in 84, go back to the angle menu, punch in degree, and then type in 15, go back to the angle menu and hit the minute button. And that's the reason why I like to convert it to degrees, just because I think it's easier. And hit enter. Okay, so x squared is equal to 259.145, blah, blah, blah. So I'm going to take the square root of that. X is equal to 16 point, and on the Regents exam, in order to get full credit, you need to write down all of, like, a bunch of decimals first, and then say, all right, I want it rounded to the nearest integer, so x is equal to 16. Okay? So it's the same thing as Pythagorean theorem. We're solving for a missing side, but we can use it on a triangle that's isosceles or acute or obtuse or anything, not just right triangles. Okay? Another isosceles triangle. In isosceles triangle, red, R-E-D. So let's say, it doesn't matter where you label the letters on your vertices, as long as once you do it, you stick with what you said. So R-E-D. R-E is equal to ED, and they're both 5. Well, obviously, because they just told us that's an isosceles triangle. And RD at the bottom is equal to 8. Find the measure of the vertex angle E to the nearest degree. Okay, So this is the first time that we're going to be solving for an angle. So it's the exact same equation. It just kind of changes it because we can't type the entire thing into our calculator. We have to do like just a little bit more work, but it's fine. So remember that the side of the triangle that we start with has to be the one that's across from the angle. So I need to start my equation off with 8 squared. Okay? So 8 squared is equal to 5 squared plus 5 squared minus 2 times 5 times 5 cosine of E, or X, doesn't matter what you call it, cosine of the missing angle. Okay? So here's where I want you to be careful. This is numbers that are squared, 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 multiply, multiply, multiply. Okay, so Ms. Tompkins just wanted to make sure that everybody was careful with the way that they type these in. These numbers are being added. These numbers are being multiplied. They're all being multiplied by the cosine. So when you type it in, the first thing that I would do is subtract the 5 squared here on both sides, and I would subtract that 5 squared. So instead of, you know, squaring this number, squaring that number, squaring that number, adding them together, then subtracting, let's just have the calculator do the work for us. I have 8 squared on the left-hand side, and I'm going to subtract over to the other side. I'm going to subtract, in parentheses, 5 squared plus 5 squared. Because I'm pretty much saying, all right, both of those on that side, I'm subtracting both of them at the same time, moving them over to the other side. I just think it's easier to do it this way. So your answer is 14. 14 is equal to negative 2 times 5 times 5 cosine of x. Now, in order to solve this for cosine, you have to divide by all this stuff. 5 times 5 is 25, and multiply that by 2 is a negative 50. So I know that it's a negative 50, but I'm just trying to prove a point about how you can just plug this stuff into your calculator really easily. So the first step was we subtracted that stuff over. Now we take our answer 14 and we have to divide the rest of the stuff. So divide negative 2 times 5 times 5. And you're always putting these in parentheses. Hit enter. So cosine of x is equal to negative 0.28. Now, this is just kind of like what I'm showing you right here. It's just kind of a trick for you to do the math a little bit quicker. There's absolutely nothing wrong with writing all this stuff out and squaring everything and multiplying all this stuff and then doing it. But, you know, we just noticed in school that a lot of kids were making mistakes when you do it out the long way. So if you kind of just use this pattern that I'm showing you, it'll make your life a lot easier. Okay? So that's what cosine of x is equal to. But I don't care what cosine of x is. I want to know what the angle x is. So I'm going to, while I have that decimal in my calculator still, second cosine, second answer. That's going to tell me what the angle x is, and the angle x is 106.26 degrees, and it wants it to the nearest degree, so after I wrote out a couple of decimals, then I can round. X is 106 degrees. Hopefully you don't think that these questions are too hard. Personally, I think that they're pretty easy. They're not too bad. Alright, let's do another one. Let's see where we are on time. We're pretty good. Okay, so this is another question where we have side, 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 and we need to solve for the angle. So the only part that's tricky is the first number I plug in is going to be the one across from that angle. Okay, so 10 squared. And I'll pull this up so you can see that equation again. 10 squared is equal to 14 squared plus 20 squared minus 2 times 14 times 20 cosine of x, and we're solving for the angle again. So because we're solving for the angle down here, we have to do those 2 steps into our calculator. So let's go ahead and do that. The first thing that I would do is subtract over to the other side these 2 square roots, or terms that have been squared. So I'm going to do, in my calculator, 10 squared minus, let's subtract all this stuff, 14 squared plus 20 squared. We're subtracting all of that over to the other side. Put in parentheses, hit enter, and that's equal to negative 496 is equal to negative 2 times 14 times 20 cosine of x. Now I need to get the cosine by itself, so while it's in my calculator still, I'm going to divide by, in parentheses, negative 2 times 14 times 20. So cosine of x is equal to this decimal. It's equal to 0.88571. But I don't care what cosine of x is. I want to know what the angle x is. So second cosine, second answer. And that's why it's important, John, to be writing these out as you go, because some people stopped here and said, oh, my angle is 0.88 degrees. That kind of doesn't really make that much sense. So don't forget to do this last step. Enter. So my angle is 27.66 degrees. It didn't tell me what to round to, so I don't know. Let's just pretend it said to the nearest degree again, so this would be 28 degrees. Alright. And we have one more question and then your homework assignment. Find to the nearest degree the measure of the largest angle of the triangle, whose sides measure 7, 9, and 12. And John, when you take this test, I want to see triangles drawn all over it, because it's really hard to do these questions if you don't have a picture. So if you're not a picture person, become a picture person, okay? The measure of the largest angle of the triangle whose sides are 7, 9, and 12. Well, if we're looking for the largest angle is always the one that's across from the largest side. If it asks you for the smallest angle, it would be the one that's across from the smallest side. So this is the angle that we're solving for. Let's call it x. And we're going to use the exact same equation again. And the same thing as before, I need to start with the segment that is across from the angle. So $12 squared is equal to 7 squared plus 9 squared minus 2 times 7 times 9 cosine of x. Let's do that in our calculator again. Let's clear this stuff out. We have 12 squared, and I'm going to subtract over those 2 terms first. Minus 7 squared plus 9 squared in parentheses. Hit enter. So that whole thing is equal to 14. Okay, and then I'm going to divide by negative 2 times 7 times 9. Cosine of x is equal to negative 0.11 repeating. I don't care what cosine is, I want to know what x is. So second cosine, second answer. Cosine of x, or I'm sorry, angle x is 96.379 degrees, and it wants it to the nearest degree, so x is 96 degrees. Alright, so hopefully you didn't think that those were that bad. Pretty much all you're going to do is either solve for a missing angle or a missing side. And here are your homework questions, and there you go.